Hi guys, welcome back. I think you're following this series, MCQ series. We are doing some important questions from the previous year exams of AEE, GATE and other state government exams. And these MCQ solving will help you in recalling the concepts with the help of simple MCQs, simple questions, okay, at very powerful. Now, yesterday you requested for power electronics, so today in this session, I'm here with power electronics questions. Let's start with the first question. I think this question you can very easily answer. Try. Yes, we are at the first question. Try to answer this question quickly. I guess you're trying, guys. Are you trying or not? I see no responses. What happened? What happened to you all? Okay, Satish Kumar has answered. It is B. Okay, I'm taking his answer and I'll go further. Guys, this is one of the beautiful concepts of power electronics. This question, my objective is not just to give you the answer. The objective is to give you the understanding of power electronics with the help of this question. I have a fixed amount of resistance, which is 10 ohms. The value is fixed amount of resistance whose value is 10 ohms. Now this 10 ohm resistance, I want to control, but I want to control dynamically. Means I don't want to keep any moving part, and I want to control this 10 ohms. Of course, if you use a rheostat, then you can change that rheostat position physically, then you can change the resistance value, but I want to do it dynamically. Okay, and with the help of rheostat, I can only reduce the resistance. Suppose if it is 10 ohms, I cannot get more than 10 ohms if I use rheostat. But if we use power electronics, you can effectively get any range of resistance from not necessarily zero, okay, in general I'm saying, yeah, in general, yes, you can get from 0 to infinity any value of resistance you can get. Okay, so with this configuration, you can get any resistance greater than 10. If you change the configuration bit, you can get any resistance less than 10. Okay, that's what the key point why power electronics is so popular. One of the key points. Okay, dynamic control, we can do it. Okay, now let's see how the effective input resistance seen by the source. You have a duty ratio given here. 0.2 is a duty ratio. 0.2 duty ratio means what? Means for 20% of the time current is going, for 80% of the time there is no current going in this. Okay, for 80% of the time. Now we know resistance is simply effective resistance. If I had to say effective resistance, simply voltage divided by current flowing at the source voltage. How much is the voltage source value, and current flowing in this, division of these two will give the effective resistance, not just 10 ohms. Okay, now this voltage may be any fixed value because I'm not controlling the voltage. Source voltage is fixed, so this is fixed to V. is fixed at V. But the current value I'm controlling. Current value I'm controlling. So the current value I'm writing it as V naught by R. V naught by R I'm writing as current. Right? V naught is where I'm taking average value of the output voltage. Till this, is this clear, guys? Till this, is this clear? What happened? What happened to you all? No responses in the chat. Are you guys there? Or else, if you guys are not there for the next question itself, after doing this question, we'll wind up this session. Okay? If you're not responding to the points, then what's the use? Huh? Okay, I think those who will watch the broadcast, I think not the live, it will be helpful for them. Anyways, Vs by V naught by R, that's what I naught average. Here I'm taking average values. All are average values. All are average values I'm taking. So effective resistance is nothing but load resistance, whatever is there, into Vs by V naught. We know V naught is equal to, it is a step down chopper in whenever you're solving chopper questions. Throughout this, we'll be solving chopper questions only. Okay, in this session. So whenever you solve chopper question, you have to quickly identify the type of chopper by looking at the circuit. If circuit is not given, by reading the script, you should be able to identify the type of chopper. Okay. Anyways, V naught is equal to delta into Vs. Delta into Vs. I'm just simply substituting that over here in place of V naught. I'm putting delta Vs. So Vs cancel, you will get R by delta. R by delta. Which means effective resistance offered across these two terminals is a function of the duty ratio delta. You keep delta 0, effective resistance will be infinity. The range of delta, what is the range of delta? Give it in the chat. Give it in the chat. What is the range of delta? Delta range? Range of delta is 0 to 1. 0 to 1 is a range of delta. So if I take that, the range of V naught is, the range of effective resistance is greater than 10 ohms in this specific case. Are you clear with this point? Are you clear with this point? R effective is equal to R by 10 by 0.2, which is 50 ohms. Satish has said it. Satish Kumar has said it, but retracted the answer. I don't know why. Anyways, keep it up. Keep it up. Okay. Let's go to the next question. I think there is a small glitch, guys. I'll be just back shortly. Okay. Just maybe a few seconds. Okay. Yeah, guys, let's go to the next question. Here's the next question. Try to solve it quickly. Try to solve it quickly, faster. Think. What kind of chopper is this? What kind of chopper is this? Just same as previous one. Same to same. It is type A chopper. Okay. Yeah. What happened? It's easy. Madhu, it's easy. You don't have to actually solve the entire question. It is asked for the simple chopper circuit shown. The average and the RMS value of currents for duty cycle 0.49. See, whenever they are giving these kind of awkward numbers, 0.49 and all, remember the one who set the paper is trying to help you. He's not trying to make it tough. He's trying to make it easier for you. We'll see how he's trying to make it easier whenever. Okay, if he's a right designer, right question designer is designing the question. Question designing also not that easy. Anyways, this is identify the type of chopper. This is basic step down chopper. Basic step down chopper. Anyways, it is said the average and RMS currents for this duty ratio. Simply average current is equal to average voltage by resistance value. Now, sir, what about this inductance? What about this inductance? Because load means you have to include this voltage is total voltage, though what are the voltage you're taking, but this is the load you can consider. So in that case, you may have to take this inductor value also, but why I'm not taking? Anybody? Why I'm taking only resistance here in the formula denominator? Tell me why. Yes, perfect. Madhu Teja has given answer also. He has given right logic also. He said clearly average voltage across inductor is 0. And the final answer he is saying I0 is equal to 9.8. That itself is giving option A is the right answer. Very good, buddy. Very good. Anyways, as average voltage is 0, total average is equal to average of this plus average of this. So this average is 0, total voltage, average voltage equal to this voltage, both are same. I have already clearly explained all these minor points in our regular course. Okay, and if you see the courses, what you see with the beautiful animations, as you know, PiSquare style, we always try to maintain that visualization so that you will get to feel the subject, not just answering. Along with answering, you'll get to feel, you'll get to apply the concepts what you learn, not just learning. Application is also very important. Okay, anyways, so yeah, you can visit our website or download the app where you will get all different kind of online test series, individual courses, whatever you want, you will get it. Okay, anyways, I0 is equal to V0 by R. Okay, you're asked to find out what? Yeah, current I0 average value. So I'm writing this one as delta into Vs is V0 by R. Okay, so delta is 0.49 into Vs is 200 by 10 ohms. This gone. 49 into 20, 4.9 into 2, which is 9.8 is the answer. Now, out of all of these, it is asked average first, then RMS. So all these are average values, they are the RMS values. Okay, so it is clearly given 9.8 means out of all these options, this is the only correct option. This is the only correct option. You don't have to find RMS well, that's what Madhu Teja is pointing out. Okay, that's what exactly Madhu Teja is pointing out. Now, what about RMS value? Suppose if the question would have asked independently for RMS value, then how do you do it? Simply, you know, I0 RMS, if I just do it for RMS value, I0 RMS is equal to V0 RMS by resistance. V0 RMS by resistance. Now V0 RMS, here average value, you will get average current. If you use average voltage, if you use RMS voltage, you will get RMS current. Simple as that. Now RMS voltage formula. Yes guys, RMS voltage formula. Here simply delta into Vs. Here what will you get? Here you will get root delta into Vs is a formula because it's a basic step down chopper. Very good, very good. Now that's the reason why he has given 0.49. 0.49 making under root is easy. Under root is easy. 0.7 you will get. 0.7 you will get if you make that. 0.7 into 200 is 140. 140 by 10 is 14. That's the answer. If RMS value would have asked in the question, then this is how you'll be solving that question. All right, let's go to the next one. Let's go to the next one. Try to solve this. Are you clear? Are you clear with the question what I discussed earlier? Got it? Good. This is easy. From the basic fundamentals, I think, fundamental theory only, I'll be able to answer this. Easy one. In DC choppers, for the periodic time T, the output voltage can be controlled by, we have different control techniques. Out of all of those, one of the popular technique what you use is PWM technique, or in this PWM technique, frequency is maintained constant. Frequency is maintained constant if it is a PWM technique. But in this question it is said by frequency modulation. In the frequency modulation, we try to maintain, here in case of frequency constant, we try to change the width of the pulse. We change the width of the pulse. That's where the name pulse width changing technique. Width of the pulse is changing. Pulse width changing technique. The change I'm writing at modulation, pulse width modulation technique. But in case of a frequency modulation technique, we will keep a pulse width time as constant and we'll try to control the off time. Turn off time I'll control by keeping turn on time as constant. Okay. So by then, if this is changing, frequency will automatically change. This is keeping constant. See, simple question. This was asked in AP Transco. This was asked in AP Transco. Okay, such a simple one. Let's go to the next question. I think it's easy, you can answer it. Come on, try. No, you don't have to like and subscribe and do all of this. Try this. Try it. Like, subscribe, do it later. Don't do it, it's okay. I know you won't do it. Do the question at least. You should do this. Okay. Yeah. Done? What's the answer? Sir, excellent teaching style. Thank you, dear. It is not just me. Our team is working 24/7 to bring the best to you. We are the only coaching institute, remember. It's not that easy. Why other people, other coaching institutes, big coaching institutes are not doing our technique, 3D animation technique? Because it's not that easy. It's very difficult. For one video, we'll make 1 week time, we'll dedicate 1 week time for one video. Okay, anyways, 200 volts DC to DC converter is turned on. I'll tell you, I'll show one day how we'll make one video. Okay, how our team will discuss for getting one video out. Okay, I'll show you one day. Anyways, coming back, a 200 volts DC to DC converter is turned on for 30 microseconds and turned off for 10 microseconds. The output voltage will be DC to DC converter Simply on and off, on and off. So let me take it as a buck converter. Let me take it as buck converter. So turned on for 30, turned off for 10 microseconds. So what is delta? Delta is equal to T on by capital T. T on is 30 micro. Capital T total time is 40 micro, which is 0.75. 0.75. So I just gave the formula V naught is equal to 0.75 into 200. If you just do that, you will get 150. Direct, simple formula. This is AP Genco question. AP Genco question. And previous one AP Transco. And previous one it's TSNPDCL. Because in the upcoming for Telangana people, it is lined up. It is lined up. Of course, for AP people, it is not yet announced. For Telangana people, it is announced a little delay. It's not a delay. Little more bonus for Telangana people. They are giving more time for your better preparation, not to forget the things. You are utilizing that time, or you are misusing that time to forget the things. Don't do that. You should utilize the time to gain more knowledge, more understanding, more practice. Okay, careful. Next question, simple question. This is very simple question. Try this. I think we got the answers. That's too slow. It should be faster. Time is a key point here, guys. Not just answering. Time is also important. In a DC to DC converter, the switch duty ratio is defined as, just now I said, it is switch duty ratio is T on by capital T. But no, this is wrong. And all other things are not in this terminology. Now you'll get confused again. You'll get confused again. It is saying something sawtooth, control, what are these? I have discussed all of these with the help of beautiful simulations also. Pulse generation, how pulses are getting generated. Okay, everything I explained in the course. So in case of PWM technique, pulse generation is happening by comparing control voltage and sawtooth voltage. Control voltage and sawtooth voltage. Okay, suppose I'm just drawing a sawtooth like this. Now control voltage, if I take it as some DC voltage, suppose like this, I'll keep changing this voltage, DC voltage, this is called as a control voltage. I'll keep changing this up and down. By then I'm generating pulses. By mean I'm controlling the duty ratio. I've given this with the clear simulations, not just hand drawn. Simulations and animations I shown you. Okay, so this is a control voltage, this is a sawtooth voltage peak value. Okay, now the ratio control voltage by peak voltage of sawtooth will give you the duty ratio, will give you the pulses, required pulses. All right, good. Next question. Good guys, good, keep it up. This is TS Transco question. This is a TS Transco question. This diagram, I gave this diagram also. I gave you this diagram clearly how delta versus per unit ripple is changing. Okay, if you recall the curve, it will be very easy to answer this question. A chopper is fed from a constant voltage, means the duty ratio of a chopper is progressively increasing. Means the duty ratio, we know range is 0 to 1. It is changing from 0 to 1, progressively increasing, slowly, step by step. And chopper is feeding RL load, the per unit current ripple would be, per unit current ripple shape, I gave you, this is going to be the per unit current ripple with respect to the delta. Per unit current ripple is this, ripple current. means at 0.5 ripple current, when delta is equal to 0.5, ripple current is maximum. Per unit ripple current is maximum. Okay. So per unit ripple current increases up to 0.5, then decreases further. I have given you a derivation, I have given you the graph in the course. Okay. Next question. I think, yeah, let's see how many of you solve this. Okay, this is a good one. Good question. From AP Transco. This is from AP Transco. Very good, Madhuteja. Good. Madhuteja, he just, I think, missed this time. Okay, he is also a student. He just missed. Some students, I think 6 students, they got last time Genco. Madhuteja is one just missed. But next time Transco, you should be cracking it, buddy. Okay. Don't miss this time. Transco time. I think you just missed in some minor genre maybe. Okay, around 5 o'clock people are requesting for the class. We'll definitely consider, but others, what is your preferred timing? Dhanuj is saying 5 o'clock will be a better time. What about you guys? Yeah, give it in the chat. Anyways, meanwhile, let me try to answer this. In a boost chopper, directly has given boost converter. Boost converter means immediately draw the diagram first. Draw the diagram first. Boost converter. Buck boost, buck boost. Boost converter will be like this. And you will have here a diode. Okay. And then for the load will be there. You can connect the load. All right. Yeah. Nobody is responding for the question. This is a boost converter. This is a load. Okay. We got the answer. Madhu is saying Vs into T on by L, but none of those options are here. You're right here. You're right, Madhu, but you have to go according to the options. Option is not saying what you're showing. What you're writing is not in the options. Now, that's a crazy part. That's a crazy part, interesting part. This is Vs. It is said inductor L. So let me take this one as L. So it is asked for rate of change of inductive currents. Okay. When the conducting switch is opened, during this opening, because once this is closed, inductor will charge. Once it is open, it will discharge. So it is asking for rate of change of inductor current. What rate it is changing? This is delta I. It is asking for rate of change. We know rate of change of current only given by inductor voltage. Let's take, if you take VL will give you, we know VL is equal to L into di by dt. L into di by dt is rate of change of current. I mean VL. Now, why I am taking this term? Because this is the only equation in this where I have rate of change of current inherently in this. That's why I'm choosing this. Though it is not said anywhere in the question, take VL, but it is asked for rate of change of current, inductive current. So yeah, inductive current, yes, there only I'm taking. When switch is open, what is the value of VL? Tell me, what is the value of VL when switch is open? I want everybody's answer. When switch is open, what is the value of VL? Simply plus Vs minus V0. Vs minus V0. When switch is open, explicitly under that condition only. Okay, because in the question it is said explicitly switch is open. Guys, power electronics is nothing but circuits. Do not think that power electronics is some other subject. You have to have a good understanding, rather a great understanding of the circuit, fundamentals of the circuits, not the deeper ones. KVL, KCL, first module, second module, these two modules, if you are clear, then power electronics will be very easy, believe me. Without having great confidence on network analysis, do not dare to enter into power electronics. Do not dare. Just module 1 of network analysis is enough, greatly enough. Anyways, now it is the rate of change of current. So di by dt I want, I'm taking L to the other side, I'm taking L to the other side. That's it. That's it. Di by dt is equal to VL by L, but see, strangely, that is also not there. That is also not there. Vs by L is there, V0 by L is there, VL by L is not there. But yeah, VL is equal to Vs minus V0. Very good. So answer is this. It's clear. Vs minus V0 is VL. Di by dt is this. Direct. Simple. Good. Most of you answered. Most of you answered. Alright. Let's go to the next question. Are you guys clear? Just give that like, the heart button. Heart button. Yeah, are you clear with this? Good. Good. At least people are listening. Okay. Anyways, let's get to the next question. Wow. This is interesting. Naresh is saying be already. Good. You have to be that quick in theoretical questions. You have to be that quick. The way Naresh is saying, you have to be that quick for theoretical questions. If it is a numerical type question or formula based question, you may have to take some time, maybe 20 seconds or 30 seconds extra. But if it's a theoretical concept based question, you should be very quick. Okay? Because time is a key aspect. When you are appearing for a gate, accuracy is a key aspect, not the time. But when you're appearing for state exams like Telangana TRANSCO, Telangana GENCO, and PDCL, SPDCL, time is a key aspect, along with the accuracy, by the way. Okay. Yeah. In a thyristor DC chopper, which type of commutation results best performance? I want the best performance. If I want the best performance, definitely the forced commutation technique, not the natural commutation, not the load commutation, definitely the forced commutation technique. Out of all of these four techniques, which options are forced commutation techniques? Tell me. These two are not forced commutation, these two are forced commutation technique. Current commutation and voltage commutation. Are we clear? Definitely current commutation circuit, there is some advantage with the current commutation technique. Can somebody tell me what is the current commutation technique advantage? Yes, the advantage is, in case of current commutation technique, one has to accept SCR rating is equal to, maximum current flowing through the SCR is same as maximum current flowing through the load. Okay. Load current, maximum current, and SCR maximum current is same. But in case of voltage commutation, that is not true. That is not true. Means load current, if it is 10 ampere, tell me what is the maximum current that is carried by the SCR? 10 ampere plus I naught into root C by L. Okay. Anyway, some extra current is there. Yet, this will give a best performance because it will give impulsive voltage across our SCR. Okay, it is also called as, suddenly it will give voltage across SCR, so it will turn off. Okay, so this will give you the best performance according to me. If there is something, especially for when you're going for where you have load fluctuations are very high power interruptions, this will be the best one. Okay, anything further? I think voltage commutation, I can say it is For Jones Chopper, yeah, the Jones Chopper is also one of the voltage commutation technique, because this question sometimes it is asked, Jones Chopper is relevant to what? It is voltage commutation. Next question. Wow. Look at this. This is, previous one was TS Genco. This question is Telangana NPDCL question. Telangana NPDCL question. Very interesting and very simple question. And to understand these questions, we developed amazing animations. These choppers and all, how current is flowing, you can just Google it. Type A chopper in PiSquare channel, you will get some amazing animated how current is flowing, because the confusion lies here with this subject is, circuit is as it is, but when you change the switch configuration, its behavior will change. So our animations will help you to understand, okay, within this switching, current is flowing like this. It will help you in a great extent. Okay. Yeah. This is basically which quadrant chopper? Can somebody say what is a type? What is a type of this chopper? Type A, type B, type C, type D. Yes. Madhu Teja has said it correctly. It's a type D chopper. Type D chopper. Okay. Type D chopper. You know, this type A, type B, type C, type D, type E, just like your USB cables, it's nothing like, you know, they have to categorize these. They call it as type A, type B, type C, type D, or class A, class B, class C, class D. It's just classification. Okay. Just like your USB cables. You know USB cables? Yeah, look at this. USB A type, USB B type, USB C type, USB D type. There are different types, right? A, B, C, D, goes on like that. Okay. Just like this, your choppers also classified like this. Based on quadrant operation. Very good, dear. Very good. Nice. Let's go to the next question. So yeah, by the way, for the previous one, answer is, it's a 2-quadrant chopper. It's a 2-quadrant chopper. To be more precise, it's a first and 4th quadrant chopper. It is first and 4th quadrant chopper. It's a 2-quadrant chopper. Very good. Very good. Next question. We're at the last, guys. We're at the last. Just 2 more questions are there. Which is the following configuration? Yes, come on, quick, speed up. Speed up. Okay, which of the following configuration used both motoring and regenerative mode? It's not necessarily you need 4-quadrant. Guys, stay here. It is said motoring and regeneration. It is not said forward motoring, reverse motoring, forward regeneration, reverse regeneration. Nothing like that. It is said motor and regeneration. So basically, 2 quadrants are enough. 2 quadrants are enough. If you just know the quadrant operation, here, yes, this diagram will help you to a great extent. V0, I0. You know I0 is proportional to torque because we're talking about a DC motor, and V0 is proportional to speed. Okay, this is forward motoring, this is regenerating, this is reverse motoring, this is also regenerating. Okay, so forward motoring or motoring and regenerating, these two combinedly can give you motoring and regeneration. These two can also give, these two can also give, these two can also give. Any 2 quadrants can give it. Any 2 quadrants can give it. Okay. Basically, there is a special type of chopper. We just saw type D chopper. Type D chopper is also having this same phenomena. Okay. Even type C chopper also. Type C also will have both these two. So basically, 2-quadrant chopper. It can be type C, it can be type D. It's not necessarily type E. It's not necessarily all 4-quadrant chopper. Okay. Of course, though that will also work. Okay. Anyways, last question, guys. This image is very important. Every line is very important in this. Every line is very important in this. Take it. Take a screenshot quickly. Next one. Yeah, try to answer this. Just based on the previous question, what I said, previous explanation, what I said, previous diagram, what I given, this diagram, you'll be able to answer this question very easily. Okay, let me give it. In a 4-quadrant DC motor drive system controlled by 2-phase controlled converters, the current and voltage of converter 1 operating 1 and 4 quadrants respectively. 1 and 4 quadrants respectively. Just now we saw 1, this is first quadrant, this is a fourth quadrant. So both voltage and currents are positive. Here current is positive, voltage is negative. Okay. So voltage and currents are positive. Which option is matching that? Current is always positive. Yeah, voltage is positive, voltage is negative here. This one. See both the cases, first and fourth quadrant just now we saw here, right? Both the cases, I0 is constant, V0 positive, V0 negative. Okay, so V0 positive, V0 negative. Option B is a perfect match for this. Alright guys, that's the end of this session. Naresh has again answered this question. Very good, keep it up. That's amazing courses at a lowest possible price. You will get everything. Power electronics. Yeah, by the way, we launched electric traction subject. We went to the train also to give you the clear view of how one can drive the train. If you watch this course, you will be able to drive the train. Yes, you can drive the train. It's that well explained with nice animations in PiSquare style. It is at the lowest price right now, 99 rupees. You can just try it out. You will have complete electrical traction subject in your hands. Just electrical traction subject. Okay, just try it out. And by the way, for Telangana people, this PYQs, guys, this PYQs, do not neglect this. PYQs 99 TGTRANSCO online practice test. You must do it. You must do it. There are some free tests also available, but free tests won't have solutions, but try free test. I'm not asking you to go for paid test. If you want solutions, then, but free tests are there, top subject wise splitted. Gate questions, previous year questions, even Telangana, recent Telangana GENCO questions. Everything is included here. Okay. You can see this. TG GENCO also included here. Okay, in content if you see, you will get some free tests. Yes, TG GENCO 2024 AEE free test. Appear it. You'll have 7,500 questions. Free tests are there. Okay, appear it. Try it. Know yourself. Know your understanding of the subject. Know your status. That's the end of this lecture. Happy learning. Enjoy the learning in PiSquare style. Have a good time. Any questions? No questions. Bye-bye.